Yo, what's up, guys? Welcome back. Welcome back to the stream. Just trying to get things sorted here. Yeah, so welcome back, guys. Jumping into some more problems today. See what we're looking at today. Take a look at our problem of the day. Dude, man, if it's the same problem as yesterday, dude. Oh my gosh, man, it's kind of shocked. Maximum difference between increasing elements. Give it a 0 index integer array. Let's move this over here. Array nums of size n. Find the maximum difference between nums I and nums j. Nums I and j, nums j. Size. Nums j. Maximum difference occurs between I is equal to 1, j is equal to nums. So nums j minus I. Okay, I think this can be a simple like brute force solution right here. Maybe not, given 0 index array. The maximum difference between nums I and nums j. 0 is less than I is less than j is less than n. And nums I is less than nums j. Okay. In range. Length nums. J. Length nums. Probably want to start in front of I, so we'll go I plus 1. If 0 is less than or equal to I, but is less than j, is less than the length of nums, then we can do the diff is equal to the absolute value of I minus the absolute value of j. Nums I. Nums j. We can return. Then we take the max. We can do. Okay, let's do res here. Res is equal to the max of res and diff. Let's set our res out here. Our maximum is 0 for now. Oh, return diff. No, we want res. Right now we gotta wait a little bit. Missing something here. Return the maximum difference if no such I and j exists. Return minus 1. Size n. Okay. From the maximum difference between nums I and nums j. Nums j minus nums I. Does that make a difference at all? Okay, but instead we want to return res if res does not equal 0. Return res if res does not equal 0, else negative 1. Let's see if this passes here. Okay, nice. Good stuff. Hopefully that submits. Okay, sweet. More on what we solved today, dude. We just solved the daily problem. Good morning to you too. Well, actually, it's the evening for me, but good morning to you, Surav. Just solved the daily problem. It was a pretty simple problem. I mean, I just did the brute force implementation of, an n squared double for loop, and then just checking the difference. So pretty straightforward. Probably gonna be checking out some other problems today. Nice. Yeah, bro. Appreciate it. Thanks, man. What are you up to today, Surav? Let's do a graph theory problem. I feel like we always start off with a graph theory problem. What do we want to solve here? Maximal network rank. Let's take a look at this one. We haven't looked at this one. The infrastructure of N cities with some roads. I gotta fix my hair. It's in my eyes, man. I need a haircut. There's infrastructure of N cities, some number of roads connecting these cities. Each road's I is equal to AIBI. Indicates that there is a bidirectional road between cities AI and BI. Okay. The network rank of two different cities defined as a total number of directly connected roads to either city. If a road is directly connected to both cities. Still new to Decode. Only got 20 questions so far. Well, good luck to you, man. Keep grinding, dude. Did I get a job? No, not yet. Not yet, Dolprain. I'm still working on it, dude. Probably not for a little bit. Probably not for at least a couple months, man. Surav. Yeah, good luck with that stuff, Surav, dude. Just keep being consistent, bro. That's the most important thing. I feel like you got your ups and downs all the time, but some days you're gonna feel like you probably suck, and some days you're gonna feel like you're goated. But the most important thing is just to the consistency and just to keep going no matter what. Because trust me, I've felt like that a million times. I kind of felt like that yesterday on stream when I couldn't solve a linked list problem that I'd solved before. So, but I mean, it's whatever, bro. It's all part of the process. So, network rank of two different cities defined as a total number of directly connected roads to either city. The road is directly connected to both cities. It is only counted once. The maximum network rank of the infrastructure is the maximum network rank of all pairs of different cities. Given the integer n and the array of roads, return the maximum. I don't really understand what this question is asking me, to be honest. Rank of cities 0 and 1 is 4. Is that because we can get to all 4 places? As there are 4 rows that are connected to either 0 or 1. The road between 0 and 1 is only counted once. True. Yes, Rav. Definitely, bro. Just keep being consistent. So I think here we just got to count really the edges. We just want to return the maximal network rank of the infrastructure. Usually when I think to myself about graph problems, I usually do an adjacency list, but I'm thinking with this one, it's probably not needed. Maybe we just count the edges here. Maybe we'll take a look at the hint. Try every pair of different cities and calculate its network rank. The network rank of 2 vertices is almost the sum of their degrees. How can you efficiently check if the road is connecting 2 different cities? Network rank of 2 is defined as a total number of directly connected roads to either city. If a road is directly connected to both cities, it is only counted once. Okay, I understand that, but I'm thinking maybe we could maybe set up an adjacency list, have all our nodes, and then kind of run a DFS on it. But I feel like there's a much better and faster way to do it. I feel like there's that's my initial kind of thought, but Total either. Connected roads to either city. Horrible problem description. At no time does it describe maximum network rank of the infrastructure. Description does not provide. It's one of the examples. Yeah, I saw that. Solution is very simple. Problem statement is hard to understand. Maybe we just gotta sum the integers. Degree in range. What is this? Roads. So if we go to 0, I have to think really simple here because I think I don't think it's very hard because the previous problems in this section were pretty straightforward. Like, I feel like it was just kind of theory problems. But in this case, why is it 4 here? It's because we can go 1, 2, 3, 4. So 2. There are 5 roads that are connected to either cities 1 or cities 2. Why isn't there 6? Why is this one left out? I don't get that. I don't understand the problem statement, I feel like. 1615. I have to figure out, I have to understand the problem better. Label 0 to n minus 1. List of roads where each road connects 2 cities. Okay. Pick 2 different cities. Let's call them A and B. The network rank of A and B is... and the number of cities labeled 0 and minus 1. 1, 2, 3, 4. Yeah. List of roads where each connects 2 cities. It's an undirected edge. Each city can be connected to multiple cities or none. Pick 2 different cities. Let's call them A and B. The network rank of A and B is number of roads connected to A plus... Oh, okay. I think I'm understanding the question now. Wish you luck. Thank you, Dolly Praying, dude. I really appreciate that. Sorry I didn't see your message come through there. Why subtract 1? Okay. Okay, I understand what we're doing with this question, right? So what we have to do is we pick an edge. So we pick 0 and 1. And we count how many edges are connected to both these nodes. And then, but if they're connected themselves, 0 and 1 are both connected, then we minus the edge by 1. I feel like this problem description was like pretty terrible for this problem, but yeah. So how can we solve this now that we kind of know about it? So Pretty much we just want to count all the edges that are connected to both node A and B we are visiting. Start at 0. Trying to think how we can code this up because I'm not 100% sure. Maybe if we made like an adjacency list or something here, right? We def adjacency list, passing our edges here. We create a hash map. We loop through for edge and edges. We can do, okay, for edge and edges, we do AB is equal to edge. If graph A not in, sorry, if A not in graph, we do graph A is equal to a new list. If B not in graph B is equal to the list. Otherwise, we go graph A dot append B, graph B dot append A. We can return our graph here. Now we call our function. Our graph is equal to adjacency list roads. Let's print our graph. So I guess we can kind of run like a DFS. Ooh. Graph. You still didn't get a job yet? No, bro, no job. No job, Dolpan. No job yet, dude. Still looking for one. 0, 1, 2, 3. We got, okay. So now we got this. Now we can do like, so now we go, okay, so from 0 we can get to 1 and 3. And then from 1, we can get to 0 and 2. Right, so that would be 5, what we're looking for, right? Because we can get to 1. We can get to 3. That's 2. We already count this edge. We can get to 3 there. What are we looking for? 4. Oh, 1 to 3. 1 to 3 is different from, we get from 0 to 3 and then 1 to 3 from here. So I think that should work. So let's do that. Let's do let's do like a DFS function. I think this is a little bit overkill for this problem, but I mean, fuck it. Let's just do it. So node 2. Let's just leave that for now. Let's go for node 1, node 2 in roads. Call the DFS function on node 1, node 2. outside of our DFS function, we can do, okay, let's do, this isn't really a DFS function. This is more something different, but let's do graph. Okay, so for neighbor in graph node, for neighbor in graph node, a rank of cities of 0 and 1 is 4, as there are 4 rows that are connected to either 0 or 1. The row between 0 and 1 is only counted once. Let's make our, instead of doing that edge case there, maybe we can just do, make our, no, but not in every instance will our count be 1. For neighboring graph node, every neighboring graph node, we can do, let's make our count to be 0 here. We can do count plus or equal to 1. We don't really need to go visit that node. We can go for neighbor in graph node 2, count plus or equal to 1. Which means we'll get that, and then we can do, well, if node 1 if we'd actually have to do a DFS function here. Damn, bro. Trying to think about the logic here. Let's do, inside this loop, we can do, well, if node if neighbor is equal to node 2, we can break count. And we can do here, well, if our neighbor is equal to node, we can break. And then we can turn our count from this. Come down here. X is equal to DFS node. We want to return the maximum. So let's make a maximum. Let's do max count is equal to 0. So then we can do, well, max count is equal to max count or X. But this needs to go below. Oh geez, I'm gonna sneeze, man. Oh my gosh. We can return our max count. That wasn't really a DFS up here, but nope, doesn't work. Oh. What are we returning here, bro? What? Oh no, this is wait. How is this our output, dude? What are we returning here? Return max count. Max count is 0. What the hell is going on here? Oh, whoops. Forgot the max keyword there, dude. 3, 5, 5. Let's print counted. Print counted. Oh, we only outputted 3. We printed 5 though. Why is that? Why? I don't know. What's wrong with my logic? We're only considering cities that are directly connected from roads list. I'm only considering cities that are directly connected from the roads list. I thought that was you're only iterating through pairs that have roads between them. I don't understand what I'm doing wrong. Actually, you should know which is what the network rank requires. Use a set. Use a set of pairs to know if 2 cities are directly connected. Try all on pairs of the cities. Is this on this? Okay, so obviously I'm doing something wrong here. Let's get rid of this function. I feel like there must be a simpler way to do this, so we can go I in range length roads. So J in range length roads. Prints. I like to visualize stuff. I feel like it's important visualizing stuff, so I range length roads. Print all unique or unordered pairs of the cities. Like 100 is already considered. It avoids self pairs. Okay, so of graph plus length of graph J. Let's print out total. Graph I. What is going on here, dude? Hey, bro, please sleep. Appreciate it, man. I don't sleep, dude. I'm joking. I do, bro. Something wrong with my key here, dude. People here in 31 mins in and people already asking for sleep is wild. People here in QT rolls. I don't know what QT rolls is, bro, but people here in I don't know what QT rolls is, bro. How's your day going, bro? Thanks, man. Yeah, my day's going good, dude. Being a long day, so trying to figure out how to do this problem though, bro. Super cities. Quant finance. Oh. Yeah, bro. Not me, man. You trying to break into quant finance, dude? Let's comment this out. Man, I hate leak code for you, dude. I can't run it straight away, dude. Okay, so printing I got a next iteration. Alright, so this is J, 03. That makes sense. Alright, because we're looking at this, then we go here, we print 01, yeah, we print the next one. We go 01 again, print the next one, yeah. Then we increase. Okay, so we're looking at... Yeah, I would love to, man. Yeah, it's definitely tough, bro. That shit's difficult, man. So we've got our adjacency list here. How can we do this? Sorry guys, I'm deep thinking, not really talking, so my bad. Trying to figure this out. Okay, so for some reason, the length dot graph dot get I, what is this, plus the length of graph dot get j this. Then we will go if j in graph I then we would subtract 1 minus equal to 1. Check the max. Probably look at our max count as equal to max count. Sorry, max. Max count. I'm blanking, dude. Total. Return max count. There we go. Goated, dude. Goated. So we get the total, we get the length of our current I. If it's nothing, we return an empty string. We get the length of an empty string. Plus we get graph.j. Hey bro, Zendrometer, what's up, man? How you doing, dude? Let's see if this submits, dude. Oh no. Oh shit, no. If j in graph.get I empty string. Oh, good, man. Yeah, that's good, dude. What are you up to, bro? Okay. Still the same one. 1 is 0, 0 is 1. Expected 1. Let's use this test case. One zero. How would that be 1? Isn't it connected to each other? Why would we get... Wouldn't it be 0? I don't know. I don't know what's wrong here. Just chilling after pulling an all-nighter. Oh, why'd you pull an all-nighter, bro? That sounds brutal. I don't know why we have 2 returns here, but yeah, dude, I don't. Maybe. If length of roads is equal to 1, return 1. I don't know. This is probably stupid. This is definitely not gonna work. But college hunting. Let's go, dude. What are you gonna study? Okay, this is definitely stupid. I'm definitely doing something wrong here. I'm missing something. I don't know what it is though, dude. To be honest, I don't know what I'm missing. What are you gonna study, bro? Yeah, bro. I have no idea what I'm missing here. Need some help. What am I missing here? Either I totally messed this up or I'm missing something really simple. Oh. Oh my gosh, bro. How am I this stupid? It's cool flag, bro. Thank you, man. Man, I was looping over roads, not the... That's why I was getting so confused, dude. I was like, what am I doing here? Oh, sorry. This is N here. Thank you, bro. I'm actually, I'm from Australia, man. My, yeah, the flag's over there, so... You from Australia, dude, or... There we go. There we go. Sweet. Man, that was so stupid of me. How the hell did I mess that up? So we loop to reach thing. We make the adjacency list. Loop to reach thing. We check these nodes. Check these nodes. Check these nodes. We pretty much brute force the whole thing. Simple. Look them up in our adjacency list. Check if they're equal to each other. If they are, we -1. Do the max. We got it. So I don't know how I was messing that. I was literally looping through roads. I was like, bro, what am I doing? But all right. That was a good problem. Guess we'll leave that for now. We'll jump into something different. I have an old friend, Aussie. She taught me to eat at Macca's. Yeah, bro. I actually live in the US, but yeah, people over there call it Macca's. It's the short term for it, dude. It's Macca's. I feel like I haven't heard that in so long, but yeah. I'm so used to just calling it McDonald's, bro. So, yeah. You should go there, man. Australia's a really nice place, dude. It's really, really beautiful place. Graph theory. Top 100 most liked, bro. Kind of want to look at another linked list problem again because I kind of failed on the one yesterday. Let's sort a linked list, man, because why not? Given the head of a linked list, return the list after sorting in ascending order. So what are we giving? We're just giving the head of a linked list. Can you sort the list of O of n log n time and O of 1 memory? When did I solve this? January. Okay. Given the head of a linked list, return the list after sorting in descending order. O of n log n. And O of 1 memory. Yeah, I don't know how to do it like that. I honestly feel like I solved this problem literally looping over this linked list, changing it to an array, sorting it, and then returning it. I mean, that's a simple way you could do this. You know, you could just loop over this linked list, add every single value, put it into an array, sort it, and put it back into a new linked list, but I don't know what the real way is to solve this, though. The real, like, Let's have a look. 140 sort list. Okay. Doing that. Okay, I'm gonna do the cheating way, and then we're gonna think about it in a different way. So, let's do cur is equal to head. Cur does not equal none. We loop through this, right? We create some sort of array. Let's do like, cool, just call it array. So why not? Loop through this and we go, okay, array.append cur.val cur is equal to cur.next. We print our array, right? See what we get here. 421, right? And then we sort it. Array.sort. Let's print it again after. At least we know we can solve it, you know, like doing it a cheating way. 1, 2, 3, 4. Then we go create a new list node, so we can go dummy is equal to list node. Dummy is equal to list node. Then we want to do, well, I think we need to put an initial value in here. Equal to dummy walker. Is it? No. Let's just do for I in array. We go cur. Trying to think here. Find array cur.next is equal to I. Cur is equal to cur.next. And then we return our dummy.next. I think cur.next is equal to I. Cur.val is equal to I. And we would just return dummy. No. Cur.next is equal to I. Oh shit. List node I. Cur is equal to cur.next. Return dummy.next. So you intern getting ready for yeah, bro. So I'm working right now. Yeah, of course I'm looking for a return offer, but I'm you know, I'm also like applying for jobs and everything, so just trying to hope for the best and everything. You know, see where I can land a position, so that's the goal. and just practicing every day and kind of seeing where it can take me. So I don't know. Let me see how I solved this last time. Okay, yeah, I did it the same way. But I'm not sure kind of how to solve this the actual way. So it seems like the actual way here is using fast and slow pointers, and using a helper function to merge them together. With our base case here, we split the list in half with the fast and slow pointer. That makes sense. Slow is equal to slow dot next. Yeah, mid is equal to slow dot next. Break the list, we recursively sort both halves. Let's take a look at discussions here. No, you can't. Bottom up merge sort. Yeah, I feel like the implement. Yeah, I feel like the implementation for this like would be unbelievable. That's right. We'll leave that for now. I kind of want to jump into something else. Take a look at a stack problem, dude. I wanted to do a stack problem yesterday, but min stack. Yeah, why not? Let's take a look at this one. Oh, no, not this one. I don't want to design one. Decode string. Given an encoded string, returns decoded string. The encoding rule is k encoded string, where encoded string inside the square brackets are being repeated k times. Note that k is guaranteed to be a positive integer. Okay, so good. So we don't have to work with negative integers here. So as a start, you may assume that the input string is always valid. When did I solve this? March. Furthermore, you may assume that the original data does not contain any digits. Digits are only this repeat numbers. K, for example, that would be input like 3a or 24. This case generates at the length of the output will never exceed 10 to the power 5. Okay, so we're looking at this. Try merge sort. Yeah, I kind of thought it was merge sort, but to be honest, man, I didn't really want to implement it. And honestly, I cannot implement merge sort off the top of my head. So, I just left it. I did it the cheating way, dude. Use an array. Like the output will never exceed 10 to the power 5. Got to think about this problem. Maybe we can get a little drawing up or something. Take a look here. So we're given this, right? We're given the number, right? So this is our stack. Probably using a for loop to loop through this, right? So I guess we can simply begin with a... Ooh. No. I feel like when we're looking at this, look through here, we're gonna have 3 on the stack, right? Okay. Oh, but there's nested ones, man. That's tough. How do we do a nested approach? Well, we see a 3. We see a bracket. So what would this be? 3. So we'd be 3 of A2 times C. So 3 ACC, ACC, ACC. ACC, ACC, ACC. A2C. And then we do 3 of that. Okay. May assume that you put strings with valid, there are no extra white spaces. Square brackets will form. Furthermore, you may assume that the It's been a while since I've looked at a problem like this. A, B, C, B, C. How do we want to think about this problem, though? Okay, so start off with a stack, all stack, and maybe I should watch a video on it again. It's been forever, dude. No, maybe not. It's a stack. Guess we have to check, well, if char, how do you check is the number? Is numerical Python. It's numerical. No, it's not like that, dude. How to check if number is numerical. Python. Is numeric? For what? Is digit? Is that one? Is digit. Is digit. Okay, I think that's the one. Char dot is digit. Okay, so if we have a digit here, and we keep the digits inside of the stack, right? So then if we see a square bracket, we add everything inside of the square bracket until it's not a digit. If we see a digit, I feel like we have to add the digit to the stack. Is that kind of the way that you want to go about this? Like, else. So if the char is a digit, then we would go stack.append char. Right? But could we have multi-digit numbers there? Doesn't really, does it say? One to 30. Doesn't say that it's a S consists of lowercase integers, digits, and square brackets. S is guaranteed to be a valid input. All the integers are S in the range 1 to 30. I feel like it could have multiple digits. I can't really remember, to be honest, but so if it's a digit, we append. We could have multiple digits, right? Else if we could see, else if char is equal to an open bracket, right? Else if char could be a closing bracket, and then else it could be a letter, right? So I feel like we should have curse string out here. So if we see a letter, we should add it to the string, right? So how we do that, we would do curse string dot add char. I think dot add is how you add a string in Python. Add Python string, I think. Format dot join. I think it is. I don't know. We'll get an error if not, but we'll figure that out. So if we see these, if we see an open bracket, what will we do if we see an open bracket? I feel like if we see an open bracket, we have to reset the string, right? So we would do curse string is equal to this. But I feel like if we see a closing bracket, we should add the current string to our stack. Right? Would that work though? So this is our stack here. Let's go with our first test case. We have 3, right? Then we look. Right, this is our curse string. Well, right, our curse string is equal to whatever's inside of these speech marks here, right? So our curse string, we get, if we see an open bracket, we reset, right? Then we would go A, because A is in here, right? This is our current string. We see A, then we see a close, and we append our current string. So then we would append A, right? So we'd see the closing bracket. Then we see a number, we would append 2, right? Because if it's a digit, we append our char, right? Then we see an open bracket, we reset. So now our curse string is back to an empty string, right? Then we see BC. We add BC because it's a char, so we add that to our current string. We go BC, and then we add BC over here, right? And then I feel like we loop through this stack, keep popping. And we would get 3A, 2BC. So I think that works. What the fuck? What a great series. Appreciate that, Web with Wilzo, dude. Thank you. Appreciate it. So I think that works for this test case here, right? But if we were to use something that's got some nested loops, I don't know how this is gonna go, so I guess we'll take a look at that. Can we make a new image, new blank image? Okay, so this is our first test case here, right? Now if we do our second test case, right, we have a stack. So we append 3, right? So our stack's over here. Are you interested in front end / creative dev, Max? I am. I'm nothing like spectacular with front end dev, but I mean I can do it, but I'm definitely nothing spectacular. But I am interested. Yeah, I'm interested in all positions really. So I kind of prefer more back end stuff, but I'm interested in everything. I'm more like kind of like logic based. So we add a 3 here, right? Because we see a number. If it's an open bracket, we have our curse string, right? So curse string. Let's put our thing here, right? We have an A here, right? We see a letter, so we add an A. We see a 2, so we add it to our stack. Okay. We see an open bracket, so we would reset. But if we reset, we don't add A. So it's not going to work with it's not going to work with a nested one. So what can we do? Right, there's a chance we're going to have to work with multiple digits here as well. Oh, go back. Multiple digits. We have closing bracket. Select out, append this. Obviously, we want to return that, right? Yeah, I feel like I'm missing something here, man. 60-minute video by Decode, dude. I don't know if I want to look at that again. Take a look at this in-depth explanation. Here's the definition of an encoded string. Concentration in these cases. This is way too overkill, man. What is this solution right here? This is insane. Bro, what is this? Like, that is way too overkill. That's definitely not. Oh, here we go. This is kind of what we're doing here. Yeah, bro, that is way too overkill. It's way more simple than that. I don't remember it being anything like that. Oh man, this is bright, dude. Jeez. Man, none of that helps, dude. Characters closing bracket. We pop characters off the stack until we find the corresponding open square bracket. Yeah, if anyone has any ideas, man, I'm actually not sure kind of what to do from here. feel like I'm missing something. Maybe I look at my old submissions. It's been a while. How did I do this? Oh, we were close, man. We had the right thinking. Range S. So we have a cur num, cur string, a stack. We loop through the value. We check, okay, is this value a digit? So we do need to do multi-numbers. We do. I obviously messed it up earlier. Also, if S value is equal to an open bracket, we reset. So that's what we didn't do. We didn't append. Why do we append cur string? Cur string and cur num. What is cur num in this case? Oh, okay. We're appending the... okay. So really what we're doing here, we're holding a cur num. So instead here we thought about appending the digits straight away into the thing, which works, but if you have a nested one here, a nested input, it's not going to work, right? So here we have to append. So we do have to build multiple digits, right? Oh, whoops. Right, so if we have multiple digits here, we have to handle that here. So we go cur num times 10 plus into S value. Let's change this to char. Range length S. So here we handle the multiple digits, right? If we see an open bracket, okay, we append. We keep this, but we append. That's what we missed. Stack.append. We append our current string and our current num. Empty string. Then we have cur num is equal to 0. So we reset, right? Okay, we're no longer looking at 3 anymore, right? We reset our old, and we pretty much reset here, right? So obviously now if you see a closing bracket, what do you want to do here? So if we're resetting here, so obviously here for this one, I feel like it's pretty straightforward. I feel like we just have to append, right? Char. Sorry, it's char. Right? But if we see a closing bracket, a corresponding closing bracket, prev string num is equal to stack.pop. So we pop from our stack. Prev string num is equal to stack.pop. And then we would times it together. So our cur string times our cur num. Well, no, we want our previous string because this is our whole previous string. Plus num times our current string. Yeah, okay, that's right. And then we would simply just return what would we return in this case? Probably Curve string. Is that what we finish with, really? Oh, okay, yeah, because we're adding here. Okay. Didn't think about that. Miss a colon here. We were close on that problem. Kind of pissed we didn't get that, but I mean, it's whatever, but char is digit. char. Need to make it lowercase. String. Get rid of that S. Oh my gosh, man. What is going on here? String has no attribute add. So it's not add. What is it? I can't remember. Okay, we just plus or equal to. Plus or equal to S char. Oh, we're forgetting curve string here. That's why it's not returning. There we go. Probably gonna work on one more problem. Ooh, frustrating we couldn't get that one, but that's okay. Maybe work on one problem. Let's just do this problem. Oh. Actually, let's do something we haven't done. That was pretty straightforward, I feel like. Are you applying for jobs? I am. Yes. I have just started my job hunt, so I guess I am currently, yeah. Maybe we can look for something in the explore, something we haven't done. Let's filter by something. I got about 15 minutes, so let's filter by acceptance range. So let's just filter by difficulty. We'll filter for a medium problem. Jump game. Actually, let's do an easy problem. Let's jump in and do something easy. Oh, we can just look at both. That works too. So, what about you, Nazareth? Are you applying for jobs, bro? Newsret, sorry, not Nazareth. Newsret. Something to do. Man, I feel like I keep scrolling. Done so many of these. So many locked problems there that we could be doing. Circular array loop. What is this? No, I'm not feeling that. Maybe we can find something on our study plan we haven't done. Oh, done all these. something in top 100 liked. I'm currently working as a software engineer, but I want to focus on AI. That's cool, man. Good on you, bro. I'm definitely excited to begin working soon. So. Diameter of a binary tree. We've never solved this, so that's interesting. Given a root of a binary tree, return the length of the diameter of a binary tree. The diameter of a binary tree is the length of the longest path between any two nodes in a tree. Path may or may not pass through root. What are you interested in computer science? Yeah. I'm interested in being a software developer. I work on my own projects, work on my own stuff, but I don't know. I just thought I'd just try and start live streaming. I don't know, just something fun. I don't know. Try something different. I originally started making videos of me leak coding on my channel. I've done about I think I did about 140 videos or something, but I thought I might as well just like switch it up and try and live stream. I don't know. So it makes it more fun, like talking to people while I do it. You know, I feel like it's kind of boring when you're grinding leak code by yourself sometimes. I do enjoy it still. I wouldn't say it's completely boring, but I feel like it's more fun when you talk to people. And at least like when I'm doing these problems and I can't really solve them, I can get help from people. So it's pretty chill. Okay. Turn the length of the diameter. The diameter of a binary tree is the length of the longest path between any two nodes in a tree. This path may or may not pass through the root. I feel like there's a similar problem to this on LeetCode somewhere. I feel like there's probably a reason why I didn't do this one. Okay, I probably struggled with it. I don't have a lot of time, so. Something I haven't done. Next permutation. You know, I'm just going to do a quick problem. We're going to go back to the sort colors one. I'm just going to do this one. Reset it. I won't look at it though. Okay, let's have a look. I don't remember doing this. Given array nodes with n objects colored red, white, and blue, sort them in place so the objects are the same color adjacent. Colors in the order red, white, and blue. We will use 0, 1, and 2 to represent the color red, white, and blue, respectively. You must solve this problem without using library sort function. Okay, so I feel like this is a fairly straightforward problem. It's a great idea, man. Keep it up. I've been thinking of making a blog website where I could discuss the things I learned just to make it fun for me. That's cool, man. I made my own portfolio website. It's got a blog on it too. It's actually in the description. I think it's on my link tree. I'm just using Gatsby for mine, so mine's like pretty simple. It's not like it's it's really just me using markdown files. It's no like back-end logic or doing anything or a database or anything with all my stuff, but it's pretty simple. So I think here we just create a dictionary, right? I assume we'd probably loop through these nums, and we just keep track of everything. So actually I feel like we could hard code this because we technically only have 3 colors, 0, 1, and 2. So I guess we could, I mean, we could probably just do 2 loops actually. So let's do my dictionary. Right, create it. We loop through. If I not in my dictionary, we can create it, right? My dictionary, I is equal to this, right? Let's just print the dictionary, just take a look at it. Alright, okay, that works, cool. Now we can loop through and go for I in nums. If I in my dictionary, which it always will be, we can do my dictionary I plus or equal to 1. I guess we could actually do this in 1 loop. We don't even need double loops. I feel like that I think that just works out right there. For I and nums, oh, we're putting my dictionary up here, that's why. Let's print our dictionary. Yeah, we got everything. So now what we want to do is we want to sort this in order. So I feel like we would probably use a lambda function here of some sort. And we would go function Python. Is using a dictionary makes it in place? Is it meant to be in place, bro? Oh, sort them in place. So the objects are the same order or adjacent. I didn't see that. Colored red, white, and blue. Sort them in place. I was thinking a dictionary, bro. That's literally the first thing I thought of. I didn't even see this in place. Oh, jeez, man, that's bright. Separate copy of the data structure, modifying it in place. Jeez, how would you modify it in place? I'm not sure how you do it in place, bro. Do you know Newsred, how to modify it in place? I don't think when I solved this problem, I don't think I sorted it in place, to be honest, but I feel like it's probably where you could probably go like, I mean, this is the cheating way. I feel like you go here and then you go for key in -go dictionary.keys. Maybe using some in-place sorting algorithm like insertion sort. Yeah, bro. I don't know. I've got no idea, man. Key and sorted. I dictionary.keys. Sorted nums dot append dictionary key. Sorted nums. This is cheating though. This is not doing it in place. Oh, we gotta up. I don't think we return sorted nums. Do we even return anything at all? It's meant to be in place, bro, but yeah, I ain't solving it in place, dude. Maybe not, dude. Oh, wait. Like this. What is going on here? Let's just print our sorted knobs. See what we get here, bro. Okay, so we're not. Oh. 222. Are we not doing this properly? Yeah. For key and sorted my dictionary keys. Damn, bro. I don't remember how I sorted this in place, dude. Man, dude. Can't solve any problems, man. Maybe we could do. Bro, I'm so hard to think about this. Color in 012. If for color in 012, we do if Dude, this pissed me off, dude. Just use a for loop in another one and find the minimum, print it, and make the value of the dictionary to 1 so you don't use it again. Okay. Hang on. Key in sorted. Dictionary.keys. Let's print out key. Hang on, I'm gonna look at it this way. Hang on. Print key. We're gonna print out key. 0, 1, 2. So let's print -go dictionary key. Can we go like for I are you talking about don't sort it with the sorted function you talking about here? Oh, you must solve this problem without using the library sort function. So you're saying use a for loop in another one and find the minimum, print it, make the value of the dictionary to 1. Okay. I understand. Okay, let me try that. Use a for loop. So for find the minimum. So you're saying like for key in my dictionary dot key value in my_underscore dictionary dot items. Find the min. Jeez, dude. So you go float infinity. If this is not gonna work, dude. Oh my gosh. Oh, another solution is each time you find the minimum key and use a for loop in range of value and print the key. You sure that works, Mose? I don't think that works, bro. And then remove the key from the dictionary and do it again. Yeah, but how, bro? If you just, like, if you're keeping track of the min value, you're only running the for loop once. Like, what do you mean? Like, because wouldn't the min key be outside the for loop, and then as you run it, it's going to loop through every single key and check its value? Before using the loop, just find the length of the dictionary so you know how many times you need to run the loop. Yes, search through all of them. Bro, this shit's pissed me off. Oh, bro. I'm getting a major headache, dude, from doing this. Thinking about this stuff. I've pretty much already done it wrong, bro. I can't remember how I solved this shit, dude. How did I solve it in place? Current range length. So this is what you were talking about, Mosey? Finding the min here. I guess we were talking about a dictionary technically, but this was me doing it in place. This is me using a dictionary. What did I do in January? So this is what I was doing. Creating a dictionary, adding it. Q, are you also applying for jobs? I am, bro. I'm applying, yeah. Hang on, my buddy, he's me in Discord. So this is where I mean, we're doing the same thing here. What are we doing? Using an index for color in my dictionary. Or something in range my dict color. Man, how did I not do that, dude? Index is equal to 0 for color in my dictionary. Something in range my dictionary color. Index equal to color. X plus or equal to 1. So we're going through each color that we got. We're looping through the range. So we're looping through each value. Nums index is equal to color. We sorted here technically in the beginning, that's why. That's why it passes. Because we sorted it over here. You have Decode Premium? Dude, no, I don't. I use a free version, dude. It kind of sucks, not gonna lie. Good luck with your journey. I just saw your LinkedIn. Try adding your stack in the About Me plus below your name. That helps with LinkedIn SEO and recruiters. Appreciate it, bro. I will do that. Thank you, man. Thank you, dude. That's why I was literally tripping myself out the whole time, bro. Like, you know, I was thinking about doing it this way, but you can't use the sorted function. So I was tripping out. I was like, bro, like, how do I even sort this without using without sorting it at all? But, I realized the way I did it is I just sorted it kind of in the beginning, which I guess is technically cheating because really you're meant to do this in, it'll pass if I just go sorted here. Yeah. Fine, range 3 for Jane. Yeah. Yeah, I agree with you, Mosey. I kind of want to think about more about how I did it in place. Doing it in place, I mean, you'd have to do it n squared, but what do we do here? How do we do it? No. What's this one? Okay, this is a real in-place solution here. Left is equal to 0 for color and range length nums. Min num is equal to float infinity. Index is equal to 0 for right and range color length nums. So what are we doing here? We're setting our min num to this. Our index is 0. We're looping right. Starting at color, going like the nums. If nums is less than right, nums right is less than min num. Find our min. Temp is equal to nums color. Nums color is equal to min num. Nums index is equal to temp. Interesting. For color. Okay, I'm gonna like kind of go along with this so I can get my thinking right. Left is equal to 0, right? That's how we reference back. Color and range like nums. We set our min num to be infinity because we want to find the lowest number. Index is 0. Then we loop right, starting from color, all the way through our nums. We check, okay, is nums right? Less than our min num. If it is, we want to save our min num to be equal to nums right. What do we do here? We make our index equal to right. Why do we make our index equal to right? Because that's where we're gonna move the integer, right? Well, why do we use the right? What do we use? Oh, we use index here. Okay. So here, this is where we move the values. Your keys are just 0, 1, and 2. Yeah, yeah. Thank you, Mosey. Yeah, I realized that. But I appreciate that. I was just struggling a lot thinking about that stuff. Are you trying to use binary search? No, bro. This is just this is sorting it in place here, bro. This is where we replace the values here, right? So we make our temp. Temp is equal to nums color. We make a temp variable. I mean, we could use the swapping in Python, but I don't know. Num's color is equal to min num. Min num is equal to num's right. Right, because this first for loop is keeping our loop, which is where we're replacing the numbers. Num's color is equal to min num. So we're swapping the values here. Num's index is equal to temp. Hey, I took my job day 200. Yeah, bro. It's tough out there, man. Hey, I took your job. Dude, I don't understand how I don't think about this, how this doesn't come to my mind. Can you use count function? That's for a dictionary, bro. I'm not using Mosey, I'm not using a dictionary anymore. I'm doing it like looking at how I did it in place a couple months ago. Yeah. What am I missing here? You don't need dictionary. Not for this one, bro, because this one's in place. When we use a dictionary, it's technically like you can do it on list. Yeah, you can do it in place. Range acknowledgement index equal to right. Oh shit, it's because it's inside the for loop, that's why. What am I doing? Are you still unemployed? No, I'm not unemployed, bro, but I'm gonna be looking for a full-time job soon, so yeah. Yeah, not unemployed though. I feel like unemployed like sounds so sad. And it's good to come back and look at these problems because I just like sometimes they go out the window, bro. So what about you, Nikita? Are you employed? He's a streamer for now. No, bro, I'm not a streamer at all, dude. I'm the furthest thing from a streamer, dude. I just do this just for fun. Just now it's more fun talking to people while you do the problems. I don't know. I have to come back in my own time, bro, and look at some of these problems, dude. It's been so long. I think I'm going to finish up here, though. I think I'm going to relax and play some games, so I appreciate all you guys watching. I'll be back at it tomorrow, probably around the same time, so appreciate you guys. I'll see you tomorrow. Thank you.